Hi. So I just used that word to get the hype, and it really worked. So uh, today, the goal for that talk, we're gonna talk about basic things over machine learning, and the idea it is, I'm a front-end developer. I'm not a data scientist, but always I was interested about to do something with machine learning. But always I think about, oh, that's a really high level thing that you never will get that. And I think the second title for that talk, it is Machine Learning for Mortal Developers. So we're going to see with 5 steps, you can do something with machine learning. And hopefully when you see that talk, you're going to be able to do something as well. Or is someone that already are doing that. I think a few people comment about Watson this morning. I say, whoa, the people are really into that. And we have like chatbots as well. The talk was really good. And for today, we're going to use a library called ML5. ML5 is a JavaScript library built over TensorFlow. The beginners, when they create that library, was to propose like, oh, we're going to do a library for artists, and they can use machine learning to create things. And after that, they changed the title for a friendly framework for machine learning. And so, my name is Fellyph Cintra, and I'm based in Dublin. As I think that I mentioned about that, I'm a Brazilian from north of Brazil, but I live in São Paulo for a long time. There I used to organize the WordCamp São Paulo. So 2012, I was in that side, was my first WordCamp. And since 2012, that's my WordCamp number 21. I will have been like as attendee and also as a speaker in different WordCamps. South America and here in Europe, basically. So when you talk about like artificial intelligence, what came in your mind? Like I think it's, the first thing that I think about artificial intelligence came there. If you know that image, you are we are at the same age, but the guy's still doing that movie like 10 years or 20 years later. They're still doing like the Terminator. But that's the image from the first Terminator. I was a kid. I watched that movie. It was really scared for me. And just for you get it that. So machine learning, artificial intelligence, it's a field that we create some code that we propose for the machine, try to take a decision over that. So we are not really restricted by that code, for example. This is a common example. When you are coding something, you have, oh, if x is greater than 200, the side will be right. If it's smaller than that, will be left side. And we pass a few data, and after that, we take the decision and we decide what is right and left. That's the normal code that we used to do. And with the Terminator, with machine learning, we first pass the data and we will specify for the machine learning. Look, that's left, that's right, and based on that, take the next decision. So it's basically it is, the machine will try to learn what is the meaning behind those data and those labels, and after that, they will start to predict something after that. We can do two things. We can also tweak our code to say that's wrong and right, and they will start to improve that result. Or we're gonna have like different ways to use that. There are like some terms that like when I always start to search about AI, that is like neural network, we have like data set, deep learning, natural learning, machine learning, supervised learning, like what else learning, and pre-trained models. We have those whole things like talking about machine learning. But for today, we're going to focus on two things. One is machine learning, and the second one is pre-trained models. Just for we get in the same page here, like who tried to do something with machine learning? Just like, cool. And who wanna do that? Who wanna like, didn't start yet, but I wanna make that. Cool. And as I told, like there is this hype to say, oh, I have this data and just pushing a machine learning and you're gonna make like a magical decision about that. But it is not so magical. There is like loads of math behind that. And the good thing that ML5 abstract this whole math, and we can just train the element and pass the data for that and take back some results in an easy way. But machine learning is like mainly mathematics behind. There is no magic. So you also need to understand that's my data, and I have some criteria to take the decision. So that's criteria like we call the feature extractor decision. We take some decisions based on features. We have features to take the decision. There is no magic behind that. You should understand the data and teach the machine, I'm going to take some decisions based on that, and after that we get the output. There is no magic behind, I pass through data and after get the result. We can get that with some tools on the cloud that they already trained that, but someone have done that before. Wasn't something magic that, machine learning, do that. Okay, that's the data, make money. No, it doesn't work like that. And if we organize those whole tag words that we used before, we have the artificial intelligence, that's the big picture, and we have natural language, machine learning is there, and inside machine learning we have different fields, and inside our decision we have the neural network. The neural network will be the part of our code that we're gonna send some inputs, and the neural network will translate that, and you gave us our output. And that output, it's just number, right? We don't pass for the machine learning, there's a picture of cat, and the machine is like, it's a cat. It's just a label, and when the machine learning do that, they just translate numbers, and based on those numbers, they say, it's a cat. But for the machine learning, machine learning doesn't know what is a cat, just a label. And for now, we're gonna use ML5. Who used an ML5 before? Just, no one? Oh, cool. And TensorFlow. Twice, cool. We have a small group here. So, ML5, as I mentioned before, it is friendly machine learning for the web. So basically, if you go to the website, it's mainly we write in JavaScript, and it's made over TensorFlow. That TensorFlow, it is made by Google, and that is more lower level than ML5, right? When you talk about low and high level, it is not if the language is really modern. No, it's when you talk about low level, we are talking about manage memory and get it like in a language, for example, C#, not C#, but C or assembly or those low level language that we need to be more specific about that. And TensorFlow, it's around that. When we train, we needed to go more deeper and do the configuration make the layers for the decisions, how many layers we're gonna use to take the decisions. For example, you have a kind of animal and a cat. So we have a few features to describe a cat. We need to find the tail for the cat, the eyes for the cat, like the mouth, the whole details for okay, this is a cat, and I classify it as a cat because I got those layers to get into a cat. But also, if you think about the tiger also have the same features that I described before. So what are we gonna make a second layer that, okay, can make the difference between a cat and a tiger? Just please, someone, I need some help. How can I differentiate?
The size or the weight?
The size. So I can decide, okay, the next layer will be the size, right? So I start to put some layers to get in a result, more specific result. So, and when you work with TensorFlow, we start to work, and those levels I need to be more specific about them. And with ML5, we have two ways to describe the features and take the decision. One is the example that I'm gonna show. It is using the feature extractor, and also there is another feature that I can use that is K and N. There is another script that we can specify. We can identify the difference between both. With feature extractor, for example, I can train the machine learning. So, oh, this is Fellyph with the left, raising the left hand. And the first one, they will understand that is me, raise my left hand. And the KNN, it's a person raise the left hand. They won't know that is me. So, and that things are like abstract for you. You just call different functions, you're gonna have those results. So we have an example that I can identify the type of the bird with ML5. I can find objects, so I can send a picture, and with ML5 they will say, oh, there is a cat in that point, there is a sunglass in that point, there is a window in that point, and there's just define that there is a cat, but not what kind of cat they have there. And also we can get some positions as well. Like with ML5, I can identify, oh, there is a person doing that position, or like dancing. So we can also use the camera to do a game, for example, like a dancing game, for example. It was a long time that I used the game for Xbox, the dancing game. So basically they use that feature like to identify the movement and do the score for for when you play that game. So, and what you can classify with ML5. So we have 3 tabs. We can classify images. So I can send an image for that. I can use sound as well to identify any kind of sound. Could be a note in a guitar, so I can play a guitar and train my ML5 to identify a note, for example. Or I can say, hey, what came Thessalonic? And ML5 will understand that I told, hey, what came Thessalonic? And after that, I can take some decision, for example, start and listen. For example, you can implement something related about accessibility, that the user want to do a comment by the speech, like comment with the voice. And you can train ML5 to identify when the user say, I want to make a comment. And you can trigger a function and start to listen the user, or like request the audio and start reading that information and pass the information to a comment box, for example. And also we can identify text. So I can like point my camera to a specific, like for example, a bottle of wine. And for example, something that I use, I'm not a drink person, but I use a lot with vino because I just want to know what they score for that wine. Sometimes I not make like a publicity. There is an app that you can like recognize the wine and you can get the score. So, and you use the camera, point to the wine and you get a score. Who used that before? Just no one? Yeah. So before I really like I bought like really bad wines. I just point and now I just like go to a store, point the camera. Okay, I say like how is your score for between 4? Yeah, like for me it's like 3.7 is still good. Yeah, 3.7. Okay, so and they do a score between 0 and 5, and so they just read the label for the wine and they just use the third one. Also, probably they can use some image to do the differentiation between the brands and the bottle, like, and that's also happen in the cloud. Just take a picture and send the image to the cloud. They will classify that, and the image come back and say, oh, that's the Chardonnay, whatever, and the score is like 3 point something. And can we do that with WordPress? That's a question. And I have learned a few words in Greek, and the answer is nah. And for me, it was funny because nah, in my hometown, we say yes with nah as well. I say, oh, I speak Greek before, and I didn't know. And yeah, so I learned that yesterday, and I learned like a new vocabulary in Greek. And so, in our steps for today, what do we have? We have this option to create a Gutenberg block or not. I just take the decision, okay, you use a Gutenberg block because I can install as a plugin, I can use in different parts, and especially now Gutenberg blocks will be everywhere, so we can include a Gutenberg block in a sidebar, or inside a post, or inside a page. So with that option, the user just drag and drop the block, and you're gonna enable the image classifier for do what you want. And the second step, it is define the label. So I need to define the label for that book. So in our product that I didn't mention before, it is a bookstore. So my goal, it is identify 3 types of books, and when I identify that book, I will point the link for you buy that book. So I just get my camera on my phone, point to the book, and the machine learning will identify that book. When they identify that book, they will say, okay, it is that book. If you want to buy, we have that. And when I start to make the example, I was like calling the product by the name, like, or just like book 1, book 2, book 3. And when I train my model, I say, oh, how can I find the product now? And I just, okay, I need to go back, train my element again. And that time, I use the label that will describe my product. It is the product ID. And when I know the product ID, I just call a REST API and catch that product with the REST API and show to the user. And after I define the label, so just pay attention that you can also create a translation for that data and jump between, for example, the name of the book and do a query to find the book by the name. But it's better you already know the ID. That will be, the search will be so much more better than find by a string. And later, I just train that. We're going to see how we're going to train. And when I train, I export my module to say, oh, I did the train for those 3 products, and I will get like an XML file and a JSON file with those informations that will be our decision maker. So it is the criteria to say that book is that book. So the machine learning have that data to say, oh, when someone show me the Martian, the book, I will look for those informations. If those informations match, I have confidence for 99% or 80% that that's the right book. And after when I export everything, I just get the whole pretender model and push inside a script on my Gutenberg block. So, and let's code. That's my favorite GIF. And our main function, so now let's talk about code here. That's not the right order. So you won't copy that and paste and it will work. No, those 5 lines, sorry, it's fine that line? That's the most important thing, okay. For example, the first, it is the mobile net is our classifier, our decision maker. I will just call the decision maker and say, oh, I'm going to use mobile net. Mobile net is something that is inside TensorFlow, and that will be the tool that will help us to take the decision. The second line, we do the classification. I just send image to the machine learning and say, look, machine learning, Terminator, look Terminator. This is book 1, book 1, book 1. And I start just send the pictures with the label, book 1. And after, I say, hey, Terminator, this is like book 2. And I send pictures for book 2 in different positions for the machine learning to understand that when someone show the book in any position, that's the book that I mentioned. That's important as well. That's also, sometimes some apps, they made a square to say, put your wine in that square because we need specifically there just to improve the performance. So if the user send that position, we're gonna send the results so much quicker. And after when we train that, when we send like different pictures, sorry, I just jump one line, we ask for our machine learning training, and they will, based on those labels, they will say, okay, now we'll start training and try to find things in common between them. When I finish that training, I will be ready to classify things. So mainly those 5 steps, yeah, 5 steps. Mainly those 5 steps, we do our application. But they will be in different places. So that code as well, if we're going to see the whole solution, it is on my GitHub. That's me. And will be on my GitHub, and you can see different examples, just like using MobileNet without any classification, create your one classification, and the third example, saving your classification, and the last example, it is loading external classification. Because you can use a default classification from TensorFlow. If you don't want to train anything, you can just send to TensorFlow, and you can use MobileNet in another module to take some decisions about, for example, I don't want to train anything, but I want to help the user. When the user want to upload some image, I want to provide them some keywords, like general keywords, like cat, dog, or book. And I can use the default module that was already trained by 1 million images. But the problem about use that, it is, for example, if you want to use something specific from Greek, or like some specific for the region here, or some specific for Dublin, that image classifier won't identify that, because inside those 12 million images, they are not so specific about Dublin. Or if they have, sorry, for example, they have something about Dublin, will be a specific place, like one bridge that are really famous, and they will understand that. But without that, outside that, they won't find. So the idea is, you can do your training, and you can identify your own things, and after upload that pre-trainer module. I will just check if I need to play on the machine, or if I can play here. Yeah, I need to go there, sorry. Yeah, here. So, and I create two labels. One, it is a basic thing. I just create this sad face. Now I'm acting as a sad people here, and I just training that. And also a happy face. And after, when I finish the training, I just click in train. And what we can see there is the machine learning training, and try to be confident about those results. When they got 0, the result will say, okay, I'm ready, you can start classify that. And after, when I get my model ready, I start your training, and as you can see here, the labels just appearing like happy and sad. But here's the second part. I create the Gutenberg block because I can just drop in my post on my page. When I drop there, I can reuse inside my page, and after, I get the classification for sad and happy. And that could be anything. Could be, for example, you can make a game to qualify image. Like you can say, like, oh, when I do that, like the product's fine. Or I can point for my camera to identify a plant, a kind of plant. I have a stores with plant, and I want to know which plant it is, and I want to buy that. I just point to the plant, but before I need to train my module to identify that plant. But for machine learning, it doesn't matter. It is just image. And what's happening here, the machine learning will slice my pictures in small parts, and you pass through the terminator, the machine learning, the neural network, and you convert that pixel, that small pixel, in an array of numbers. And you get a list of this array of numbers, you will save that. So inside the machine learning, those informations like happy and sad is not my face like happy, it's just numbers inside that. And so now we did the training. Just questions until now? Yeah, please. Sorry, I messed up the whole presentation. Just one question. Sorry, can you just say? Yeah, so.
It could identify your sad face again.
Yeah, so I can label that image as me, or
Okay.
I can send, for example, I can send 10 pictures of me, like my picture, and say that's Fellyph, or I can send 20 pictures of 20 persons and say, oh, that, for example, 10 pictures of Brazilians. Oh, this is a Brazilian, and I can identify a Brazilian. But it will be just me, it will be other people. And the feature extractor will try to identify something common between those pictures and say, oh, it's a Brazilian. Or for example, in my case, could be me because it will be my face in different states, like with bird, without bird. But you can identify or yourself or for example, a man or, okay,
Yeah.
that's answer.
But your face,
Ah.
for example, here you train the model.
Yeah.
So can
If someone else came and smiled, you mean that?
If it's you,
Yeah.
but in different room, with different shirt, with a jacket,
Yeah.
perhaps,
So-
it could identify that you are happy or sad.
Yeah, yeah. So the shirt won't, like if I'm sad, doesn't matter because they will find a partner between, okay, there is an orange shirt there, but he's still sad. The label is the same.
Okay.
So the feature extractor look for, is not like something that they look for a shirt. For the machine learning is a number. And they will match those numbers and say, oh, Fellyph's sad, even if the shirt change. Something that can confuse it is, if I use the shirt with a happy face, and I use this and I change the label, and after I change the color, maybe I can mess up, but like that's better you use different examples. Okay, I just like made a question for you to get the same page.
Okay, thank you.
Good, thank you. Sorry to mess up the whole thing. So, and now I got in the stage that I read training the model, and I export the model as well, and now, when I get my feature extractor ready, I would say, oh, don't use the training that you have on the cloud or in memory. We have already a file that will specify what you're going to looking for. We're going to read our machine, like my module, and after I will say, okay, go start class. When you are ready, start to classify that. So, and when you do that, that's my function. When I got the result, first, I check if there is any error. If there is no error, okay, get. For me, I use the confidence level to decide if that book is that book. For example, in my case, I told that when confidence got in 85%, okay, when the confidence got in 85%, I would say I'm with the right result. That's the book that I mean. You can define your confidence to say, oh, if the machine learning getting 7%, it's fine. Or it's something more specific. I just wanted that result with winning 99%. I can specify on that stage. And later, if I get the result, I will say, that's your product. If I don't get the level of confidence, I just print again. Please show your book. Just say, keep showing, please. I don't know what it is. And after, I just have to classify again. So that function is like running over time. You know, I just calling like the classification like every single time, because if I change the product, my label will change. Oh, that's book 1, that's book 2, and book 3. When I got the whole training module now, so as you can see the screenshot, I have just product 2 and 1, and you can see the level of the confidence, sometimes like 94% and sometimes like 52%. If I play that now, so I have those 3 books, and when I show the image, when they understand that that's a book, just appears here, buy it. Like, it can be anything. I'm really poor design, so sorry the designers in the room, but was just the code. But you can like put those elements any place, just the idea that you can do. So, and that's a test, like I just like try to mess up with the identification. I just put like 2 books together after I start change. And they start to identify the book, like, and after, when I just, okay, now I want to buy that book. For example, it's a solution that you can use your phone and you point to the book and they'll say, oh, that's a book X and Y. When you press there, you go to the page of the product, or you can also include directly the product in your cart, for example. You can go straight to the cart. And so that was a solution with those lines. It was, I don't know, less than 20 lines, so we abstracted like many things. But that's just possible because I use like ML5, and also there is a library called P5 that abstracted many things over the JavaScript that sometimes I just call, give me the camera. I just abstract the whole thing to get into navigator.get in media or something. So, and I had to specify like many different examples, like where we can use that. So we can identify products, we can classify products, and that classification could be inside the Gutenberg editor as well. So I can get in a stage, for example, I wanted that, for example, in my e-commerce, I want to help the people. I just want to help them. When someone uploads the picture, I just, okay, that is the book, The Martian. I don't need to let the people type every time when they post a picture about the Martian book. When someone just send that, I can suggest inside the editor, oh, that's the book that you want to include. And we can add like image effects as well. So for example, I can put something that really common. I can put a sunglass or do some examples over that. And there are like different things that we can do. And the things that I commented before is the KNN. The KNN, it is the point it is someone with the left hand and the right hand. It's not like Fellyph. And the feature extractor, it's a heavily, like, they go to more deeper. And the size of the module is like 5 megabytes when I go more than 2 products. Because when I start like going to like different layers, the size of my module is like exponential. And just to finish, coming soon, it's something that is on the draft. So shape image recognition, it is a draft for browsers. So there is a draft inside W3C that they start to specify the support for face shape recognition. It's a shape API. That's a draft. If you go to Chrome now, there is a feature that's hide bar flag. So you need to enable that flag. And if you enable that flag, you can identify a barcode inside the browser. You don't need, like, for example, ML5 to identify barcodes. You can identify text as well and face. But won't be Fellyph's face, will be someone's face, someone else's face. So this is like coming soon in the future, I hope so. And when they do that, like, we won't need for basic stuff, for example, identify a bug, we won't need call a library. We just call Navigator dot read the text, for example. So those are the items. The links, the first link, it's my GitHub. The whole examples are there. Don't judge my code. If you want to create a issue, please create a issue, complain about something. And I did that code like 1 week. I was like testing, like take picture. The time that I recorded that video was like 2 a.m. I was like really tired. I said, oh my God, I can't believe that I'm showing that. The second link is ML5, the website for ML5, the P5, the library that I use it, and the last one, it is a really cool course. It is a YouTube channel that is called Cody Train. Cody Train is really good. He knows that. Yeah, the guy is really good, and they explain really well other stuff like neural network and TensorFlow and ML5JS as well. So, obrigado and Efaristo, right? Questions? Questions? Any questions? Oh.
Hello, thank you for
Hi.
your presentation.
Yeah.
2 questions. One,
please do it.
is the whole procedure, how can I say it, RAM consuming or disk drive consuming? I mean that when you train the machine, the model keeps expanding or calculates the differentials?
So
just to conclude, so you need time with the machine, or you just need capacity or tech specs?
Do you mean like when I have like a huge label?
I see that you show the book, and you again show the book,
Yeah.
and again you show the book, and again you show the book. So the video keeps recording, and it gets bigger and bigger and bigger in megabytes. So as long as you train the machine,
Yeah.
the actual data that you provide keeps growing. So this is my first question. Sorry, I have a second one too. And if it's not, if it is, you need a lot of hard disk space. Are there any libraries that you can share or co-share or maybe combine?
So let's try to. So the first example, the books, I was like doing. I did different trainings. I did one that I just sent 3 pictures. Another one where I sent like 50 pictures. And for the feature extractor, the difference, it is not the number of pictures, but the number of labels. If you start like send more labels, the size will be bigger. With KNN, the size is more stable. That won't change. Like if you send more labels, the file will change a little bit, but because the way that they translate that image, it is a different calculation. They use like they call like the KNN is the next neighborhood. There is a Kenner next neighborhood. They try to if I have it is a matrix. Sorry, we're gonna get really deep here. It is a matrix, and inside that matrix I have like different labels, and they classify based with the point, and that point it's moving inside that matrix, and the item that is more close, they say, okay, that's the classification. And for that, won't change so much because the points that decision makers are just like 5, and you just use 2 coordinations for decide. And that won't increase the number of images that you send because it is based on input. When the picture that I show about the neural network, it is always input. The layers of the calculations that always will be the same, the features decision, and after the output. That's one. The second question.
The second one is, can I use your library to use it to train my machine and then use my training too and combine those results?
Yeah, you can use 2 different like modules. You can take 2 decisions. If you get it, understand about the layers, you can combine the layers. For example, the example about the cat, I can get like another script that decides the size, and I just mix with my layer, and I say, okay, based on those 2 information, that's a tiger. Okay, it is like. For example, there are other solutions that we can just send everything to the cloud and let the cloud decide that. Like, for example, Azure or Google Cloud. There is some solution that we can do in the cloud as well. Questions?
I want to ask you, the training is done in front end?
Yeah, the whole training for ML5, the training is made on the front end. It is everything.
It is a good idea to use the front end from someone.
Yeah, so I need to train first. So the solution that you can take, it is, you have the Gutenberg block, you have the editor view, and you have the front end view, right? And you can specify that on my editor view, is the script responsible to training that. And on my front end view is the script that loads my training model and do the classification. That's one option with the front end, because the data is still going to the cloud. When you use like mobile net, we still going to the cloud to take those decisions. But if you wanna do some on the back end, you can, for example, use the upload folder to train your model.
I can upload, the client can calculate in his browser the training model and share it to my backend. And combine them.
Yeah, we can. Yeah,
okay.
we can.
Do you believe it's a better idea to calculate in the front end?
Yeah, I think the best scenario. This is just like do an example with 20 lines. Mm-hmm. But for me, the best example is when you do the whole training and the whole thing on the back end. And you can use the ML5 just to load the module and take a decision.
I didn't like JavaScript so much.
Yeah.
Because I didn't think in machine learning, I can believe that it's very good, like a language.
Yeah.
Okay, that's the way I'm asking. Okay,
Yeah,
thank
so
you.
for me, JavaScript, like I'm front-end dev, so I feel more comfortable to do that with JavaScript. But I think TensorFlow is made with Python. You can use Python.
Yes,
Yeah.
yes. Python or WebAssembly like Rust, C++,
Yeah.
Go,
Yeah.
yes.
If you know that better.
Thank you. Okay, thank you.
As I told, I'm a mortal developer. I still know the front end.
Okay, thank you very much.
You have time for one question. Okay, it's fine. Okay, cool. Thank you again. Okay.